T-minus 17. Final guidance release. We'll expect engine ignition at 8.9 seconds. 10, 9, 8, 7. Ignition sequence started. All engines are started. We have ignition. 2, 1, 0. We have a liftoff. We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center with the Saturn V.
What's going on, folks? So, welcome back to exploration of the exoplanets. My name's Ethan Moore, and today we're going to be covering HD 189733b. Now, I know it's a mouthful, but last week we were covering AU Mike B, and I mentioned that I wanted to cover a bit of a more interesting exoplanet. Well, HD 189733b is that more interesting exoplanet, to say the least. Okay, it was discovered on the 5th of October 2005, and it orbits around HD 189733a. Yes, you guessed it right. You see, I think it just could have been named better. HD 189733a is a K-type star, but if you want to learn more about that, you'll have to read about it, because this is exploration of the exoplanets. Now, let's talk about HD 189733b. It looks like a really habitable, nice little place, right? 95 light years away from Earth. It looks like it could be a tropical destination for your interstellar species in the future. Look at that. That's where our sun is in relation to it. It looks so close. It could almost be Earth. No, don't be fooled, because HD 189733b is deadly. It is absolutely deadly. Actually, here is its orbit in relation to its star. That in itself should say something. It orbits really, really close to it. Now, why is that, you may ask? Well, there's a couple of different reasons, but it's a hot Jupiter. So we know, and we've seen a lot of other hot Jupiters that do this in terms of exoplanets, and that in itself could be a whole different topic, and we'll be covering a lot more hot Jupiters in exploration of the exoplanets. But let me give you some stats on this guy, just to show you, how crazy it is. It's 13% larger, or it has a mass of about 13% larger than Jupiter's mass. And the planet completes an orbit around its host star every 2.2 days. That is very, very fast. I mean, how long does it take us to complete an orbit? Right, 365. So 2.2 days is very fast. And it has an orbital speed of about 152 kilometers a second. Very, very fast planet. Now, it looks blue. So why is it a hot Jupiter? That doesn't make any sense, right? Well, one of the reasons for the blueness is a thing called ray light scattering. And there could be a little bit of molecular absorption there too. But we don't know for sure. All of this is hypothesized to a certain extent. But I really want to focus on something a little different from what we traditionally go through here in exploration of the exoplanets. And I'll jump into the NASA stats after, but this planet was one of the first exoplanets that we were able to come up with a ton of data for, including a map of the planet, which is pretty crazy. In 2007, the Spitzer Space Telescope, wow, that one was hard to get out. It was used to map the planet's temperature emissions. Now, this is crucial because the planet and star system was observed for 33 consecutive hours, starting only when the night side of the planet was in view. And it was able to discover a lot of interesting stuff. The region of peak temperature was offset by 30 degrees east of its substellar point, as predicted by theoretical models of hot Jupiters taking into account a parameterized day to a night redistribution mechanism, which is pretty interesting. It has winds of about 8,700 kilometers an hour, or about 5,400 miles per hour, blowing from the day side to the night side. And in terms of its makeup, we see that it has a lot of interesting compounds hanging out on that blue surface of it. The Hubble Space Telescope was able to confirm the presence of water vapor, neutral oxygen, and also the organic compound methane. Yes, methane. Later, the Very Large Telescope observations also detected temperatures should cause the water and methane to react, replacing the atmosphere with carbon dioxide. Because we don't really know how the methane originally got there, because the planet's high is about 700 degrees Celsius. So this is a really hot planet, right? This is a really hot planet, and it's nothing like you would expect. But wait, there's more. The weather on HD 9733b is deadly. As mentioned, the winds are really fast, but they're also composed of silicate particles. So not only do you have very fast winds, like 5,400 miles per hour, but those winds are filled with tiny pieces of glass. that sucks. That sucks, dude. That is not the planet you want to land on, to say the least. Actually, NASA came out with this poster, and it's I think it just describes HD 189733b perfectly. Oh, you sweet blue planet, you. Oh man, it is quite the place. Now, I'm not gonna lie, it probably wouldn't be the first place on my planetary travelogue, but I would like to go and get into an orbit around this guy, because I feel like it would be the closest thing to home that we would have out there in interstellar space. It would look, it looks quite similar to Earth, but it also has amazing views of its sun. Although I don't know if you could even get into orbit that close to its massive sun. It would be pretty sketchy. Now let's just dive through the NASA statistics here. Can breeze through a couple of these. Although there's that 5,400 mile per hour winds I was mentioning. All in a sickening spiral. That just adds onto it. I didn't know it was all in a sickening spiral. Well, I guess if it blows from the day side to the night side, it's in a spickering spiral. A sickening spiral. Yeah. It's definitely not the planet you want to land on. It orbits a K-type star, as mentioned earlier. And it's, we'll just jump over to the planetary comparisons here. Its orbital radius is 0.0313 astronomical units. Its orbital period is 2.2 days. And its orbital eccentricity is 0. Planetary comparisons. So there it is up against Jupiter. There it is up against Jupiter. Up against Jupiter, it is 1.13 Jupiters, which is crazy. And then there's HD 189733 compared to our sun. It has a mass slightly smaller than our sun. And if you were traveling in a car, it would take you 722 million years to get there. Or on Voyager, it would take you 1 million. What? That's a nice round number. And traveling at the speed of light, it would take you 65. Wow. Well, there you go. And this is the observatory that observed it first in France. It looks pretty cool. I would totally go there one day. Nonetheless, oh, beautiful HD 189733b. What will we do with you? It is quite a planet. Anyways, folks, I hope you enjoyed this episode. Get ready, because we have a couple of more hot Jupiters coming up on the list, and a couple of even crazier exoplanets soon to come. Nonetheless, I hope you enjoyed the content. If you did, don't be afraid to subscribe. We'll talk to you later. Bye for now.